Hey everyone, I want to look at two more examples of using the quadratic formula in kind of more special cases. So in this case, you'll notice we know what our a is, it's 5, and we've got our b is -4, but once again we're missing that c value. So our c is like an invisible plus 0 back here, so c is going to equal 0. And then our equation equals 0, so we've got it set up correctly. So when we do the quadratic formula, it'll be x equals -b. So in this case, notice we have a -4, so it's going to go -4 plus or minus the square root of b squared. So make sure you do your parentheses around your -4 squared minus 4 times a times c all over 2a. So if you want, you could do this in the calculator. Sorry, it's supposed to be a 5. Oops. You can do this in your head or in the calculator, up to you. I'm going to show that calculator that we were using before again. So remember, we're using desmos.com/scientific. So you're going to start with clicking the fraction button. So on the top, -4 turns into a +4. And then we can't type plus or minus, so we're just going to do plus, and then square root of -4 squared minus 4 times 5 times 0. Hopefully you know 4 times 5 times 0 is going to equal 0, but if you want to type it in, you can. And then 2 times 5. So this is telling me that one of my solutions is 0.8. So on your paper, you would write down 0.8. Then remember, we're going to have, if we have one solution and it's not 0, we should check, well, we should check for a second solution just in case. So this time, instead of doing a plus sign, we're going to do a minus sign. So we're going to just go back to your calculator, delete the plus, put in a minus, and our other solution is 0. So our two solutions are 0 and 0.8. So that means when I was graphing a parabola, one x-intercept would be at 0 and the other one would be at 0.8. And that's what our parabola would cross through. Let's check out one more, just kind of problem that's set up differently. So this one has the p squared, so I know it's a quadratic equation, and it's got a p and a constant. So I need to get them all on the same side in order to use the quadratic formula. So I'm going to move this -8p over. Because this -8p is not a like term with either of these, it's going to be our middle term, because notice here we had x squared, x, and then a constant. Here we have our p squared, then we need the p, then the constant. So it would look like 2p squared minus 8p plus 8 equals 0. So then our a is going to be 2, our b is -8, and our c is +8. So when we plug this in, I know we've got this giant thing in the way, but it's going to look like -8 plus or minus the square root of -8 squared, make sure you use the parentheses, minus 4 times 2 times 8, all over 2 times a, which is 2. So finally, we're going to type that into the calculator. So we can delete everything we just did. So we're going to have -8 is a +8. So we'll have +8 plus square root of -8 squared minus 4 times 2 times 8 all over 2 times 2. So our first 0 is going to be 2, and then we're going to change the plus to a minus, and the second one is also 2. So this one actually only has one solution. So when I come back here, if I split it up, I'd be like, it's 2 and 2, but really 2 is the same spot, so 2, x equals 2 is our only solution. So in a parabola, what that means is at x is 2, our parabola is just going to touch there and then bounce back up. All right, now you've seen some special cases, so why don't you guys go and try out some quadratic formula problems.